Hello students, in previous class I think we have seen on coded inequality and we have seen the base method of doing things. Okay. Yes, as we were discussing, we have already seen coded inequality and we have seen the basic way where by concentrating on few variables, you can simplify inequality problems, but it still had some lacuna, some is not up to our uniqueness standard, right? We are still following the way that many people are doing, but is there an efficient way, particularly doing these coded inequality problems? I would say yes. So let's see that. So we'll see the basic way, like we have discussed in yesterday's class. We'll solve this problem by the basic way, and then we'll see. I'll teach you the most efficient way. By the way, this is an CSAT previous question. Now let's get into solving. Okay, a plus b means neither smaller nor equal. So which means if it is neither small nor equal, then it should be greater. A minus b is not greater. If it is not greater, it has to be the other two. So it must be smaller or equal to. Next, a into b means a is not smaller than b. Not smaller means either greater or equal. So either greater or equal. Next, a divided by b means neither greater nor equal. That means it needs to be smaller. See, you need not go on verifying for each case. There are only three operations here, right? Lesser than, equals to, and greater than. If I say if it is not 1, that means it has to be the other two, right? So in this way, if he says 1, consider the other two. If he says 2, consider the other one. It is all just subtracting and seeing. And next, this means neither smaller nor greater. That means 2 are not equal, it must be equals. Okay. Now next, and he has given some statements based on this. P into Q. What does into stands for? So let's convert this. P is greater than equal to Q, and P minus T. Minus stands for lesser than or equal to T. Next, T divided by R. Divided is stands for T is lesser than R. And next, R this sign means equals to. So R equals to S. Now he has given the statements are Q and T and Q and S. So Q, T and S we need to consider by observing these logically or by arranging these logically. We need to consider the relationship between Q, T and S. Now since Q is common, let's start from Q. So Q will write things smaller. If there is a possibility of greater, we will write greater things this way. So this is Q. So P should be greater than or equal to. So the realm of P is this way. Either it can be equal or it can be greater. So this is P. Next, P is lesser than or equal to t. So, if this is P, that means either this must be T, because T is either greater or equal. If P is equals to T, it will be here. In the greater case, it is this way, since we are denoting greater this way. Next, T is smaller than R. So, since R is greater, T smaller than R means R is greater than T. We have R this way and R equals to S. So, R equals to S. Now, we have observed the logical diagram, and then now let us get to the conclusion. Q, it means that conclusion 1 tells that Q must be equal to 2. Always remember, conclusions means it should be, it is possible in all the possible cases. Even if in one case it fails, that means it is not the conclusion there. It is not a possibility. We are talking about conclusions, not about possibilities. So, Q is equals to T. Even from seeing itself, even if you assume that for Q to be equal to Bt, you need to satisfy two assumptions, that Q is equals to P and P is equals to T. This needs to happen, then only this will happen. But there are chances, because it is not only one thing that is associated. P is greater than or equal to Q. So, there is a possibility that P is greater than Q. So, this does not stand. Okay. Now, let us go for S plus Q. Plus means greater. S greater than Q. So, even if you make everything equal, where do you see S here? S is greater than, because we said all the things that are greater are this side and smaller are this side. From the logical diagram, you can observe that S is obviously greater than Q. So, this stands. So, this much time you need to spend on this by basic method. Now, I will tell you a jugaad way. It is called LM method or Laila Majnu way. Whatever the conclusion they give you, they gave you Q is equals to T, okay, and S is greater than Q. These are Lailas, and the other variable is Majnu. Okay. Now, your Laila has to meet your Majnu, and in order to go, she can only travel if there is an opening. Assume this greater than symbol as a door being opened like this. So, the only direction of travel that is allowed is either this way. Laila is not supposed to travel this way. Okay. And remember, if there is equals to also, she can travel. There are certain conditions, but just remember these two. Now see, S should be greater than Q. So, your S should travel towards Q. Now, start here. S is equals to R. You can go to R. Next, R is equals to T. You are able to go to T. And from T, you are able to go to P, because it is all door opening. And from P, you are able to go to Q. So, from this stands S is equals to Q. So, the statement 2 stands. Now, statement 1, Q is equals to T. That means Q needs to travel to T. Let us start from Q here. Q at the first instant itself, because you can only travel in this direction. Laila can't travel in the opposite way. Okay, it can't travel from the conical section. Now, start here. This is P greater than or equal to Q. Since we need to reach from Q to T, in the first instance itself, she is unable to travel to Majnu. So this is gone. It is that simple. How much time does it take? If you remember these two rules, 2 seconds. It may seem naughty or it may seem sillier, not naughty, sillier, but this can be used for any such coded inequality. All you need to remember are just two rules. One, you need to make Laila or L travel towards Majnu, and for that to happen, she can only travel in this open way. She can travel in this way, but she can't travel in pointed direction from here to here. Suppose if this is A to B, she can travel from A to B. Suppose if this is C to D, she can't travel with the pointed end first. She can travel with the open end first. Just remember these two cases, all coded inequality can be easily solved. Oh, you seem very happy now. Good. But you see the difference? This is the normal way or the basic way that we have discussed yesterday. It is much more, it is not complex, but it is time taking. That it is sure. You need to check whether things are, suppose, what if we use much more symbols to do? The complexity increases exponentially. So the better way to do is this way. So from now on, if you see a coded inequality, since you are being my students, you should always use this LM method, because me being your teacher should help you in some or the other way to differentiate yourself from others. So like all the topics we have seen until now, we have told you some or the other way to do it much more faster, less prone to mistakes, and in much more better ways. So just like that, for coded inequality, always follow LM method. So let us see some more examples from this.